So today we are going to start by learning properties and how to name ionic compounds. So for today, I would highly suggest two things. Number one, this is our polyatomic ion chart, guys. Polyatomic ions are something we're really more going to talk about next class, but we will briefly mention today. You guys, please print this out and start working to familiarize yourselves with them. And I would highly encourage you guys to memorize them, especially if you're planning to take AP Chemistry next year. These have to be memorized for AP Chemistry. There are quite a few of them, but start to familiarize yourselves with them. I would make flashcards, make a Quizlet, something like that, just to kind of get familiar with these polyatomic ions. Even if you don't memorize them, it'll help you so much just to be a little more familiar with them. So that is number one, is this polyatomic ion chart. It'll be found on Canvas. I'll link it here with the notes as well for you guys to use. And then the second thing that you are going to need is your periodic table. We're naming, you have to have a periodic table to be able to name. So your periodic table as well for all of these notes videos, you're going to want it to be close to you. Okay, so let's jump on in. So we should have learned from last class kind of the basics of ionic compounds. They form when electrons are transferred from one element to another. They typically form between a metal and a nonmetal, but they can also form between polyatomic ions. So let's start talking about them. Okay, so ionic bonds are formed when an atom that loses electrons easily reacts with an atom that has a high affinity for electrons. And so basically we have our metal typically is going to lose electrons. Our nonmetal is going to gain electrons. So in losing electrons, our metal is going to become positive. Our nonmetal is going to be negative, and then they're going to have charges, right? We know positives and negatives attract, so they're going to be held together by their mutual attraction, and it's a Coulombic attraction. All right, it's the attraction between their charges. This leaves one particle positively charged, which is the one that's lost electrons, that's our metal, and then one particle negatively charged. Positives and negatives stick together, and so they are attracted, and they form this cool lattice structure of our positives and negatives. So you can kind of see, we'll talk about this more in a minute, but you can see down here what it's going to look like. We have that positive and that negative, and they're attracted, and so they're going to form a structure kind of arranging the positives and negatives in a way that they are able to interact and are attracted to each other. Okay, so ionic compounds in general are made up of a metal and a nonmetal. So if you remember our periodic table, on our periodic table we have our zigzag line. So everything to the left of our zigzag line is going to be a metal. Let me try that again. Come on. Ah. And then everything to the right of our zigzag line is going to be a nonmetal. All right, so a metal and a nonmetal. A metal and one of our polyatomic ions. Ammonium, which ammonium is one of our polyatomic ions. Ammonium is NH4 positive 1, and a nonmetal, or ammonium and one of the other polyatomic ions. So those are your four possibilities that we can have with our with ionic compounds. But in general, it's made up of one cation and one anion. That's the thing. It has to have those charges. So one positively charged substance, one negatively charged substance. That's what makes it an ionic compound. Compounds are made up of that positive and that negative. And so those positives and negatives are attracted to each other. And so they're going to be attracted and they're going to kind of hold together due to their attraction of that positive and negative. And it's called a Coulombic attraction, just the attraction between charges. We talked about Coulomb's law a little bit at the beginning of our last unit, periodic trends. And so in ionic compounds, they are packed together in a repeating pattern or array called a crystal lattice. So they're in a crystal lattice. And a lattice structure, basically each cation or positive charge is surrounded by an anion. Each anion is surrounded by cations and vice versa. This is a really stable structure, and it actually gives ionic compounds a lot of their properties. So these are kind of images to kind of help you get an idea of what the lattice structure looks like. So our positives are surrounded by negatives, and our negatives are surrounded by positives. So ionic compounds have several kind of unique properties. And the first one is that they are, in general, they are all hard, brittle, crystalline solids. So crystalline kind of means they look like have a crystal shape. They have a very geometric shape to them. Like if you think about salt, if you look at it, it has that kind of typical, it's kind of the typical ionic compound shape. And they are all solids at room temperature. All ionic compounds are solids at room temperature. Their melting points, so going from a solid to a liquid, are generally greater than 300 degrees Celsius, so they have really high melting points. The liquid state would conduct electricity. So liquid conducts electricity, but solid state does not conduct electricity. Many are soluble in water. We do have some exceptions that aren't soluble. Those are something we'll talk about next semester with our solubility rules. And then when they do dissolve in water, they conduct electricity. So don't conduct in solid, would conduct in liquid, and conduct when dissolved. All right? So there you go. That is kind of basics of properties of ionic compounds. So now let's jump into how do we name them. All right? And we're going to learn how to name them and how to write their formulas. So let's start with naming. All right, for now, we are only talking about binary ionic compounds. So binary, bi means two. So binary compounds are made up of two elements. All right, these are very simple ionic compounds. They're only made up of two elements. All right, so all we're going to do to name them is we have the cation and the anion. So our cation, typically a metal, is written first, and its name remains unchanged. So if you have sodium, it stays sodium. You don't change the ending of that one. And then our anion is typically a nonmetal. It's written last, and its ending is changed to IDE. There should be no superscripts or charges or numbers in ionic compound names at all for these binary compounds. So just metal, non-metal, change the ending to IDE. All right. So let's go ahead and start with these first ones. So it says write the correct formula or name for the following compounds. Since we're given the formula, we are going to write the correct name. So for this first one, we have NaCl. So Na is our metal, so its name is going to remain unchanged. So Na is sodium, so it's going to stay sodium. And then Cl is chlorine. Its ending is going to change to ide. So instead of it being chlorine, it's now going to be sodium chloride. Pretty simple. All right, let's do the next one. So in our next one, we have MgO. So Mg is magnesium. Metal, its name remains unchanged, so it's just going to be magnesium. And then we have O, oxygen. You're going to drop pretty much all of it, and it's going to become oxide. So magnesium oxide. All right, then we have CaCl2. So Ca is calcium. And then Cl2 is chlorine. Change the ending to IDE, so it's going to become calcium chloride. Okay, I'm going to do a couple more with you and then have you guys do a couple on your own. All right, so here we have Li3N. So Li is lithium. So our metal's name remains unchanged, so it's going to stay lithium. And then we have nitrogen. So we're going to drop the ending, and it's going to become nitride. Okay, you guys do the next two, pause the video, try out naming on your own, and then restart the video to go over them. Okay, so the first one we had ALP, and so that one is going to be aluminum phosphide. So Al, aluminum, stays the same. P is phosphorus. change the ending to IDE, so it becomes aluminum phosphide. And then same thing, BaBr2, Ba is barium, and then Br is bromine, so barium bromide. Okay, that's naming just these very simple ionic compounds, these binary compounds. Okay, now then we are going to practice on our ionic formulas. So you guys may notice that in our compounds we have subscripts, and there's no way to tell just from the formula where the subscripts came from. So we have rules in order to write these formulas. All right, and I am just going to say the rules I follow are these, but they're a little different. And I just say we are going to swap, drop, and reduce. Those are our rules for writing our formulas. So swap, drop, reduce. All right. So the negative sign of the anion is dropped down when the number is moved down. Ones are assumed and don't need to be included. Parentheses are used to separate subscript numbers when you need them. And then if both have the same charge, we will reduce them as much as possible. So to be able to do this, it involves, you need to be able to know what the charge is from the periodic table. So I'm going to quickly go over with you guys what our charges on our periodic table for different substances. So if we start over here in group 1, in group 1, everything has a positive 1 charge. Group 2, everything has a positive 2 charge. Our transition metals in the center are going to have varying charges, and we'll talk about how to name them and how to figure out their charges next class. Group 3 is going to have a positive 3. All right. All of our metals down here are transition metals underneath our zigzag line, except for aluminum, are transition metals, and so they will have varying charges that, again, we'll focus more on next class when we talk about transition metals. And then over here, group 4, we have negative 4 on top and then positive 4 on the bottom. Group 5, negative 3. Group 16, negative 2. 17, negative 1, and then our noble gases don't form charges. So once again, positive 1 right here in group 1, positive 2 in group 2, all of our transition metals, including those under the stairs, we will talk about more next class. Positive 3, negative 4, positive, negative 3, negative 2, negative 1, 0. All right, so that is how we determine charges based on where they are on the periodic table. All right, so let's look at how we do this. So for our first one, we have potassium chloride. So first things first is we need to determine the charges of both potassium and chlorine. So potassium is K, and potassium is in group 1. So because it is in group 1, potassium is going to have a positive 1 charge. And then chloride would be chlorine. Chloride would be, so chlorine symbol is Cl, and because it is in group 17, it has a negative 1 charge. So here is where it begins. All right, so step 1 is we need to swap. I'm going to move this over to the other side so you can see a little better. So step 1 is to swap. All right, so our 1 from our potassium is going to come down next to our chlorine, and the 1 from the chlorine is going to come down next to the potassium. Then we drop. All that means is that our positive and our negative signs no longer matter. Then we reduce. We don't reduce every single time. We only reduce if we can. So since these are both 1, we can't reduce those down to a lower number or like a lower ratio. But if they were both 2, for example, we could reduce it down to both being 1 if they're a lower ratio. So then we have our formula. All right. So we have potassium, which is K, and the number from chlorine is 1. 1s are assumed, so we don't need to write it. Then we have Cl. Once again, it should have a 1 next to it. 1s are assumed, so we don't need to write it. So the formula for potassium chloride would be KCl. All right, let's keep going. So next we have lithium sulfide. So lithium is Li. It's in group 1, so it has a positive 1 charge. Sulfide is sulfur, so that is S. It is in group 16 or group 6A, and so it has a negative 2 charge. So now we're going to swap. The 1 from lithium is going to come down next to the sulfur. 2 from sulfur is going to come down next to lithium. Drop our positives and negatives. Our charges no longer matter. And then reduce. We have a 1 and a 2. So those can't be reduced down any further because we already have the lowest ratio between those numbers. So our final formula is going to end up being Li with a 2 and then S. And the number next to S should be a 1. 1s are assumed, so we don't need to write it. So our final formula would be Li2S. Okay? Now this time we have calcium oxide. So calcium is in group 2. So it's Ca, and it has a positive 2 charge. Oxygen is in group 16. It's O, and it has a negative 2 charge. So we are going to swap. All right, so swap your charges. So 2 from calcium goes down next to oxygen. 2 from oxygen goes down next to calcium. Drop. Our charges no longer matter. And reduce. Now, guys, this is the first time we can reduce. So since these are both 2, so calcium is 2 and oxygen is 2, they can both be reduced down to 1, to the lowest ratio between them. So since it's 2 to 2, it can be reduced down to 1, and our final formula would be CaO. All right, let's do a few more together. So this time we have strontium bromide. So strontium is Sr, and strontium has a positive 2 charge. Then we have bromide, which is bromine. Bromine is Br, and it has a negative 1 charge. So we're going to swap, drop, and reduce our charges. So swap, the 2 from strontium is going to come down next to bromine, and the 1 from bromine is going to come down next to strontium. Drop, positives and negatives no longer matter, and reduce. We can't reduce on this one, so we end up with SrBr2 as our final formula. Okay, I'm going to do one more with you guys and then leave the last one for you guys to do as practice. All right, so this time we have barium phosphide. So barium is Ba, and it has a positive 2 charge because it's in group 2. And then phosphide would be phosphorus, and phosphorus is in group 15, so it has a negative 3 charge. So we're going to swap, drop our charges, and reduce. We have 2 and 3. Those can't be reduced down further, so we end up with our formula as Ba3P2. All right, you guys try to do aluminum oxide on your own. Pause the video and we will go over it once you guys have finished. Restart the video when you're ready. Okay, so aluminum is in group 13, so it has a positive 3 charge. Oxygen has a negative 2 charge. So we are going to swap. So the 3 from aluminum is going to come next to oxygen. 2 from oxygen is going to come next to aluminum. Drop. Our charges don't matter anymore. And we can't reduce this one because we already have our lowest ratio. So we end up with our final formula being Al2O3. Okay, guys. That is simple ionic formulas. Hopefully this is helpful and you feel good about them. But if not, please, please, please stay after class and ask questions, email your teacher, set up a tutorial time, whatever you need to do, because this is probably next class we're going to add another layer to this naming. So make sure you understand this one before we go back. Definitely do some practice because it's going to be very beneficial to you if you work through the practice problems and really make sure you have this one down before moving on to the next one. All right, guys. Awesome. Have a good day.